I'm recording now, by the way. I just finally got that set up. What your teacher should have told you is that the law of cosines is a generalization of the Pythagorean theorem to non-right triangles. It still works on right triangles, but what I mean is we only use the Pythagorean theorem on right triangles, but the law of cosines is the Pythagorean theorem adjusted a little bit to handle when we don't have the case when we don't have a right angle. If we look at this picture here, if for a moment, if you could imagine straight taking this angle measure here at C and making it a right angle, so changing the angle here so that the side becomes vertical um, or perpendicular to the side AC, then this formula here, the cosine of C, the cosine of 90 is 0, and this whole other term, this whole term over here would disappear. So if we made this into a right triangle, then the term that's being subtracted from the right-hand side would all turn to 0 because the cosine of 90 degrees is 0. It's 0 times all of these other quantities would still remain 0, and we would end up with the Pythagorean theorem. So the law of cosines is a generalization of the Pythagorean theorem to non-right triangles. And so when you're stuck trying to solve a triangle and you can't use the Pythagorean theorem because it's not a right triangle, then maybe the law of cosines will be helpful. Law of cosines will be helpful in the example on screen 5 that we were unable to solve using the law of sines. Let's go through a brief proof of how this why this is true, so that you're not taking this on just blind belief because I said it. So I'm going to drop this value in here. I'm going to label this little side right here D. B is still the whole entire side length over here. I'm going to label this E right over here. And let's see what we can do with this. Well, I got a right triangle over here, and I got another right triangle over here. So let's use our Pythagorean theorem on those two right triangles. So for number one, we're going to have d squared plus, let's call the height here h, since it is a height, h squared. D squared plus h squared is going to have to be equal to c squared from triangle 1. Now from triangle 2, we're going to have e squared plus h squared equal to a squared. Now, if you notice in both of these expressions here, we have h squared specifically. So let's solve both of those equations there for h squared and then see what we can do. So here, h squared is going to be c squared minus d squared. And over here, h squared is going to be a squared minus e squared. And since both h squareds are the same, meaning they're equal to each other, we can set c squared minus d squared equal to a squared minus e squared. Since c squared minus d squared is h squared and a squared minus d squared is also h squared, then those two things have to be equal to each other. Now, if we're trying to get the third version of this one here, let's move this d squared over. So we get c squared is going to be equal to a squared plus d squared minus e squared. So just added d squared to both sides. Now, if you're looking at our formula over here, you can see that there's no e and there's no d in there. So we have to get rid of e and d from this equation so that we can, and we have to get b involved in angle C in order to get to match our pattern here. Now, I will note that from our picture here, I'll write this right under here, b is equal to d plus e. That's pretty easy to see, I hope, right? So that means angle D, I'm sorry, side length D is going to be B minus E. So let's plug that in for D. down over here. So c squared is going to be equal to a squared plus b minus e quantity squared minus e squared. Now we have to expand. Now let's be careful here because some students make mistakes when they expand. Some students think that if you have x minus y squared, that is equal to x squared minus y squared. That is not true, okay? Those two things are not equal for all values of x and y. Under rare circumstances, it can be, but not in general. Remember, if we were going to expand x minus y quantity squared, that's got to be x squared minus 2 times x times y plus y squared. That you can get by making a generic rectangle and doing the little bit of algebra that goes in that generic rectangle, if that's how you do it, or you could FOIL x minus y times x minus y, or you could just know that this is the pattern because you've done it so many times, like me. Anyway, let's go ahead and expand here. So I'm going to get c squared is equal to a squared plus b squared minus 2 times b times e plus e squared, and then minus e squared. Hey, this is looking pretty good here. So I got c squared is equal to a squared plus b squared minus 2 times b times e. Notice the e squareds are going to cancel there, e squared minus e squared. We almost got the formula. We're just missing the, the cosine and one side length in there. I got to get rid of this e from the expression. So let's go back up to the triangle for a moment. How can I figure out something to get rid of e? Well, I need cosine. So if I use this little right triangle over here, number 2, cosine of angle C, let's write this up over here. Cosine of angle C is equal to the adjacent E divided by the hypotenuse A. So that means side length E is equal to A times the cosine of angle C. So I can go plug that in down here for letter E. We said E was going to be A times cosine of angle C. And that's exactly what we had up there, although we did commute the order. Multiplication is commutative, ladies and gentlemen. So if you want to switch the order so it looks exactly the same, then we've just proved that the law of cosines equation is true for this particular example. All right, now let's return to our Desmos activity. You can now solve screen 5 if you haven't already done so. Looks like many of you have. My screen sharing is paused. For those who need to see that triangle again, here's this. Okay, Skylar, do what you got to do. All right, let me start commenting. Good job, Giovanni. Good job, David. Good job, Samuel. Isabel, Gabriel, you guys are off to a good start, getting a first side there. Good job, Karen. Sophia, you're rounding too much, but you have the right rounded values. I mentioned earlier, try to go to, go to 3 decimal places unless the problem says otherwise. Looks like some of us still need time. One, you're rounding too much. If A was 9 and the other side was 9, then it'd be isosceles, and it's not. It's close, but it's not. So don't round that much, please. 3 decimal places. Good job, Elizabeth. Put a question mark next to anything you want me to check, because I've told some people that their work looks good, but I haven't told everybody. I'm not sure who I told. I don't remember. So if you want me to give you a comment, include a question mark. Josh, yeah, you're off to a good start. Keep going. You got to find all missing angles and sides. The first step would be to find A using one of the three law of cosine formulas. They're really the same. Good job, Juliana. Andy, you got side A correct. Now keep going. Get the rest of the rest of the angles. Argentina, I disagree with your value for A. Um, but you got to use the rest of the formula, Cyrus. You're not. You got that -2 times the product of the two sides times the cosine of the angle. All right, let me start to set this up here. I'm going to get rid of this work that I did earlier that didn't help us out. It is actually helpful later on in the problem. There's a little hint. So I want to figure out side A. I know these two sides here and the angle between them. So A squared is going to be equal to 9 squared plus 11 squared minus 2 times 9 times 11 times the cosine of 52 degrees. And then for that, you do have to take a square root and then to just run it through your calculator. So A is going to be the square root of that mess. And when you do that, you get about 8.95 something. I don't remember. It's 9498 or 950. It actually is a fair rounding to 3 decimal places. So far, so good, Ashley. Haley, your angles are off just a bit. They're in the ballpark, but they're off by a couple degrees. I'm not sure where the error is. All right, I'm going to continue to work this problem out, but for those of you who have correct answers or are confident with their answers, you can go on to screen 6. All right, now that we know side A, we can now revert back to the law of sines to finish the problem. The law of sines, just because there are fewer terms, fewer things in the expressions, this is a little easier to work with when possible, because you don't have so many things to manipulate or move around. So I could set up the sine of 52 degrees over side A. And we know side A is this 8.950, but I want to put an exactly equal to sign here, and 8.950 is an approximation. So I prefer to try to be exact when I can, but that's going to be equal to sine of angle B over 11. Now I would multiply both sides by 11 to get the sine of B by itself, and then I would have 11 times the sine of 52 degrees over A. And then I'd have to use the inverse sine function or the arc sine function. Now remember, for A, you're going to plug in that 8.950, or maybe even using more decimal places. And then if you do that, you're going to get, let's see, which one am I doing here? Make sure I pull the right number. That's that one. 75.5867. 75.587. My apologies. And I don't even want to bring that up. Some side issues, stuff's coming up outside of school related, but nothing I want to talk about just yet. And once you have that angle measure, and you know the angle measure for A to find angle C, you can use the triangle sum theorem. You don't have to use the what do you call it? The law of sines again. So measure of angle C is equal to 180 minus 52 degrees minus measure of angle B, which we just found as that 75 point whatever. So the measure of angle C is about 52.413 degrees. Hopefully this is clearer for those who are struggling a bit. Sure. All right, for a screen 6, the triangle looks like, sorry, just getting things the way I want them. $10.51 here, 111 degrees here, 7.05 here, and how did I label it? Q, R, and P. So for those who couldn't quite see it, just giving people time to solve. Good, Giovanni. Good, Noel. Good, Samuel. I disagree, Alan, with your value for R. Crystal, I agree with your value for QR. All right, well, no, actually, should it be labeled QR? No, not QR. You mean QP. You have a mislabeling there, but it's okay. Karen, you have the correct value for R. Valeria, correct value for R. 3 decimal places, Josh. Although your values are correct. Remember I mentioned 3 decimal places like 12 times today? Sorry, that's me not centering myself the way it should be. Sophia, I disagree with your angle measures. If you notice, Sophia, your angle measures are more than, would add it to more than 180. Ariana, I disagree with your value for R. Argentina, your R is correct. Ashley, you're good to go. Alessandro, you're good to go. Juan, you're good to go. Isabel, your side length R is mostly correct. You're up to the 6. The 1/8, I don't know, it's a little bit off. There's a little bit of rounding error in there. Maybe when you typed in the numbers, you typed in, maybe you forgot a 0 before the 5 or something is what I'm thinking. You guys want more time or shall I begin? Two more minutes. Check your missing number. Oh, yes, you got it correct, Cyrus. I didn't realize you left it in the picture and not in the, I'm not checking the pictures for some strange reason. Monique, you're doing well in the pictures. Matt, you're doing well. Just got one more angle to solve. Both Monique and Matt have one more angle to solve. Matt, I'm not sure I can read your numbers. No, yeah, you're good. Don't worry, that's gonna be a complaint for me as well, for my numbers. Don't round so much. Gabriel, you're rounding too much on your angle measures. All right, I'm going to get started, ladies and gentlemen. In fact, you know what? I'm going to open up screen number 7 for those who want to continue moving ahead, those who want to see me solve. You can see me solve. So let's call this little r. And r squared is going to be equal to 10.51 squared. I don't like the way my numbers are coming out here. Plus 7.05 squared minus 2 times 10.51 times 7.05 times the cosine of the angle between those two sides, which is 111 degrees. And then when you work this out, I'm not going to write the square root step. You know it's there, but this works out to be, what was it? 14.604 with rounding. And now if we want to find angle P, then the sine of angle P, actually, let me do it this way. The sine of 111, so I'm consistent with what I wrote earlier, over R is going to be the sine of angle P divided by the 10.51. And so we know R, so it's P we're looking for. So sine of P is going to be 10.51 times the sine of 111 degrees over R. And so P, angle P, is going to be the inverse sine of 10.51 times the sine of 111 degrees over R, which is our approximately 14.604. And when then you run that through a calculator, you get a number. Looks like you get 42.212. You can do the law of sines again if you want. I'm just too lazy and don't care to, and I'm perfectly fine using the triangle sum theorem. So 180 minus the 111 minus the measure of angle P, which is at 42. This should be degrees right here, ladies and gentlemen. And then when you run that through your calculator, you get 26.788 with rounding, 26.788 degrees. Questions, comments, concerns? I did open up the next screen. So you can go on to, I have to draw it. I know I have to draw it, yes. But how many decimals are we supposed to use when for R when we are dividing? Well, depends on the calculator, really. If you're using, the more the better is the general rule. If you want to be accurate to 3 decimal places on something like the AP calculus exam, then you're going to want to have probably 5 decimal places in your number when you manipulate that through multiplication, division, or whatever. If you're using a calculator where you can name the value, a variable, and then use that variable, it's even better because it'll be more accurate. I hope that wasn't too confusing there, Haley. All right, let me draw the picture for screen 7 for those who aren't able to access it. 9.61 on this side over here, 7.36 and 10.97, and the angle vertices are marked T, U, and V. What's this announcement? Looks like some people are getting some work done. I'm just going to pretend to be patient over here and let you guys work. Giovanni, I'm not agreeing with your value for you, which is throwing the rest of them off as well. No, the 94, Giovanni, I still disagree with. I'm not sure what you're doing wrong. Ashley, I agree with your answers. David, I agree with your answers. Samuel, I agree with your answers. Alan, I agree with yours. I agree with yours, Ariana. Angel, I agree with yours. Gabriel, I disagree with your value for you. Karen, I agree with yours. Andy, I agree with yours. Okay, thank you, Josh. I was going to say there's no angle A in the picture, Josh. So I was a little confused. 3 decimal places, please. But other than that, you're correct. Giovanni, if you could maybe draw or write down in the sketch pad area there what you're trying, and I can give you some uh, perhaps some support figuring out where things are going wrong. Noel, I agree with yours. Put question marks by yours if I haven't given you a response and you want one. It's actually not going to be 250, Josh. It should be 249. Believe it or not. I know I'm getting nitpicky, but I'm trying to teach you guys better. I'm trying to get you guys better. Juan, yes, with the last digit being a 4 and not a 3. There you go, Giovanni. Haley, I disagree with your angle T. Cyrus, what you're typing in right now is not correct. The 7.36 is not an angle measure. It's a side length. You cannot take the sine of it. Doesn't make any sense to take the sine of it. Matt, I agree that one of the values should be about 79, one of the angles, but not that one. One, let me double check. Yeah, Juan, you're good to go. The heck did I just do? Edson, let me look. No, your angle T is fine. Except for maybe the rounding. Oh, you know what? It is slightly off after the 3.6 is a little bit off. I think we have some rounding issues there. It should be after your 2, it should be a 4.9. That might be just a small typo somewhere also when you were working out some of the sub problems. You're good to go, Giovanni. All right, just same pattern. I'll open up screen 8 for those who want to move ahead for a moment, but I'll start working on screen 9. I'm sorry, 7. All right, so it's a good habit for these things to start solving for the longest side or largest angle. So I'm going to put the largest side first. And at this point, it's a bunch of little bits of algebra or arithmetic that I didn't work out. So I'm not going to simplify anything here. I sort of apologize, but you should read there's not a lot of sincerity in that apology. I just go to the computer and let the computer do all the heavy lifting for me because it's faster, it's more accurate. But if you're going to do a little bit of work, you could square all these things and multiply those things and then do it. But again, I'm just not going to. And from typing that into whatever graph calculating utility you're using, you get 79.334 degrees approximately. I wouldn't use the law of cosines again to solve the next part. I would go ahead and use the law of sines because again, there are fewer terms in the law of sines. And since I know the measure of angle U, the sine of angle U over 10.97 is going to be equal to the sine of angle V over 9.61, and there are fewer things to manipulate here. And remember, we know angle U, and so you can, multiply both sides by the 9.61 and get the sine of V as 9.61 times the sine of angle U divided by 10.97. And then angle V is going to be the inverse sine of this mess over here, 9.61 times the sine of angle U over 10.97. And again, angle U, so it's just a matter of typing all of that with the value of angle U in there into your calculator. And then you work out to get V is 59.417 approximately. And then last but not least, to find angle T, just subtract from 180 the measure of angle U and the measure of angle V. Let the calculator do all the heavy lifting, and you're going to get 41.249 degrees approximately. Got one more example to practice, just like this one on screen number, is it 8? Yeah, I think it's screen 8. Yeah, screen 8. Some of you are probably almost done already. Those speedsters in the class. I'm going to draw screen 8 in just a moment. I'm letting those of you who are still copying copy. All right, screen number 8. That's weird, Giovanni. You get the same answers I got. Wow, David, you did too. So did Ariana. We must all be wrong. Just kidding, ladies and gentlemen. Good job to you guys, to you people. Karen, I disagree with your, well, let's see. I think it's you. Your angles don't add up to 180. Yeah, your value for you is not correct, Karen. Sorry, my dog's a little angry at something. That guy. Thank you, sorry. Sorry, ladies and gentlemen, I had to answer the front door. My son locked my wife out. Samuel, I'm not agreeing with any of your answers at the moment. Put question marks by your work if you want me to check, because I don't know who I gave thumbs up to. One more time, Karen, I disagree with your letter, your angle U value. The others, V and T, are correct. Andy, you're good to go. Ashley, yours are good. Monique, you're rounding a little too much, but in the picture, maybe it's just hard to fit it in there, but I think you're doing it correctly. Juan, you're pretty good. The one little correction I'd say is your angle T is not a whole number. It does have a decimal. I know some of those digits are zeros at the start, but it's not that many zeros, at least not on my calculator. There's only 3, and then the third, after the third zero, it's large enough to round the third zero to a 1. So you can go 001 if you'd like. Samuel, your values for your first two angles are correct. I disagree with your angle U, the last value. If you look at your values, they don't add up to 180, so you know that there's something that's wrong. It's the third one. Also, the 17 is not a whole number. It does have a small decimal. I disagree, Isabel, with your angle T. Angel, I disagree with your angle T. I actually disagree with all of your angles. They're very, very close. Angel, let me see. Yeah, you're check the way you're entering things in the calculator. Maybe you're doing, maybe you've transposed a number or something slight, because you're so close that it just looks like it's a typo somewhere. Probably not a major misconception. Gabriel, your angle U is too small. In this picture, ladies and gentlemen, I know it's, we shouldn't believe our pictures. This picture is drawn to scale though. And if you look at angle U is obtuse, greater than 90. And so your angle, if it's not greater than 90, is incorrect. Don't always trust the pictures, but I'm just to give you an indication for this one. I did construct the triangle to be in the correct proportions. There you go, Samuel. Alan, I disagree with your angle T. You're in the ballpark, but you're off just a smidge, just a little. Gabriel, you got angle T correct. Karen, if you just do the triangle sum theorem to get angle U, well, addition and subtraction, get it pretty quickly. Valeria, angle T is not a whole number. I mean, it does start with those two digits, 17, but there is a little bit of a decimal there. Elias, I disagree with your values. Everything's, yeah, well, the V is kind of far off. Yeah, they're off, Elias. You need some work on those. Cyrus. No, after your subtraction, Cyrus, the 15.13 should not be there. It should be the 5.76. The two values that you're squaring on the same side of the equal sign as the subtraction part are the two numbers that go in the parentheses. So if I go back to my notes and show you, let me scroll up here to when I devise this. Notice the A and B right here. We have A here and we have B here. It's those same two quantities, those same two side lengths that are on the same side of the equal sign. Or I can go back up here, show you those from this perspective. Same thing. Notice we have B and C right here, and I got B and C on this side with it. So whatever two values you're squaring on this side, those are the two values that go right here. Okay. That's the pattern. Now you have it correct. Yes. Now go ahead and solve for U. All right, I'm going to get started here. Oh, sorry, I see a question mark. I disagree, Haley, with your values. I think maybe angle V is correct. V is correct. Your angle U is not, nor is angle T. If you look at the picture too, angle T is opposite the smallest side, so angle T can't be the biggest angle. It's got to be the smallest angle. So that's a little bit of an indication of something has gone wrong. All right. Again, my advice is to always, if you're given an SSS case where you know the three sides and you're going to set up the law of cosines, my advice is always to solve for the largest angle first. If the angle is obtuse, you want to, and it is in this case, you want to find that out sooner rather than later. Whoops, I need to change the color. Let's see, 15.13 squared will be equal to 10.78 squared plus 5.76 squared minus 2 times 10.78 times 5.76 times the cosine of angle U. I'm going to jump ahead, ladies and gentlemen, to the value of angle U. It should be capital. And not show you all the algebra. It's the same algebra I did above. I would subtract these two quantities, and then I would divide by the other quantity. Subtract these first from both sides, and then divide by what's left here, and then take the inverse cosine. And if you do this, you should get 129 points. Of course, I didn't write it down, so I got to go back to my calculator. 823. And if you're not getting that, let me know. We can try to problem solve, troubleshoot. And then after that, once you know the sine, or once you know angle U, you can take the sine of U and divide it by the opposite side, 15.13. Set that equal to the sine of angle V over the 10.78. And then we know angle U, so we're solving for angle V. So angle V is going to be the inverse sine of 10.78 times the sine of U divided by 15.13. You'll run that through a calculator and you'll get 33.176 degrees as your approximation. And then lastly for T, you'll get 180 minus the measure of angle U minus the measure of angle V. When you crank that through your calculator, you'll get 17.00095 or just 17.001 degrees. Shall we take a little bit of a longer lunch today, ladies and gentlemen? I think it's about lunchtime, wouldn't you say? We're before noon. Let's see what time on the clock. I got 11:52. If we go to 12:30 for lunch or take a break until 12:30, it gives you about 37.5 minutes. It's a little longer today. I don't think anybody has any complaints about that, right? Go take a break, start your homework, eat some food, get some fresh air, whatever you feel like. See you in a bit, ladies and gentlemen. Come back at 12:30.